for our speaker?
Yeah, actually, Jet, I'll be doing the honors to
Okay.
of introducing Kelly. Kelly Beatty of Sky and Telescope. We've known him for many years, and we had the pleasure and the privilege of working with him at Sky and Telescope for 12 years. Kelly was there much, much longer than us. So Kelly is the senior editor of Sky and Telescope. He joined the staff in 1974 and also served as editor of Night Sky, the magazine for beginning stargazers from 2004 to 2007. So after 43 years of pounding his keyboard, Kelly retired from full-time work in early 2018, but he remains actively involved in the many activities of the magazines, including tours for chasing solar eclipses. So he's a veteran solar eclipse chaser. Now, Kelly specializes in planetary science and space exploration, and he conceived and edited the new solar system, which is considered a standard reference among planetary scientists. And he is also a well-known educator of astronomy, and he has been honored by the American Astronomical Society's Division of Planetary Sciences with many awards, including the Harold Mazursky Award in 2005 and the Jonathan Eberhard Journalism Award in 2009. And recently, the American Geophysical Union's Cohen Award for Sustained Achievement in Science Journalism. Now, Kelly hails from Madera, California, and holds a bachelor's degree in geology from the California Institute of Technology and a master's degree in science journalism from Boston University. In 1983, asteroid 2925 Beatty was named by the IAU in honor of Kelly and his marriage to Cheryl. So, ladies and gentlemen, please join me in giving a very warm welcome to our guest speaker for tonight, Kelly Beatty of Sky Telescope, who will be talking about darkness in distress.
Thank
Kelly?
you very much. Thank you, Edwin and Imelda. Edwin, we're going to have to get together and edit that introduction down. We didn't leave any time for the talk, so we'll just take questions at this point, I guess. No.
We can skip to the Q&A.
We'll fast forward to that. Hey, I am deeply thrilled and so honored that you asked me to come and make this presentation for your annual National Astronomy Week. I know it's been going for more than 30 years now. It's quite a long and enduring part of the fabric of astronomical outreach and just participation there in the Philippines. And I'm really thrilled to be here tonight. As Edwin mentioned, I've known him and Imelda for close to 30 years now. They must have skipped out of the Philippines and headed to Sky and Telescope right after establishing the Astronomy Week, I think. So tonight we're going to talk about a problem and maybe some solutions to light pollution, something that has been growing ever more of a problem, I'm sure in the Philippines, certainly here in the United States. So let me just call up the talk and get it started. Slideshow from the beginning. I hope you can see that okay. If you can't, well, too bad. So let's start with a quote, and this is a sort of sets the stage for what we're going to be seeing and talking about. With lights and ever more lights. Let's see if I can get this to advance better. There we go. We drive the holiness and beauty of the night back to the forest and the sea. Now, this is a feeling, an expression of disgust with night light pollution that could have been written last week, but in fact, it was written almost a century ago by a writer who spent a year on Cape Cod, which here in the United States is a fairly dark place. So we're going to talk about what we've lost and how we can maybe get it back. But first, let's talk about what light pollution is. You know, I think you know it when you see it. It's artificial illumination of the night in all of its forms. Now, we think of light pollution generally as that, but we can kind of subdivide it into things like glare from a harsh light, trespass from one property to another, disturbance of the natural nocturnal ecosystem and landscape. Basically, you know, a lot of the light that we generate at night does not hit the ground, what we call the task area. Instead, it goes up into the sky, and that's where we have a problem. So I'm going to show you a light here that's here in Chelmsford, Massachusetts, where I live. This is very common in the United States. In older communities, established communities, they want to reinstall this kind of antique-looking period lighting, we call it, to hark back to a time when, you know, horses were on the main street and so forth. But I want to call your attention, I think you can see my cursor, to this light bulb, which is right here, hanging up in the middle of the light. Well, when that gets turned on at night, it creates light in all directions, up, to the side, down, and that's a really good example of all that can be bad with an outdoor light. But I'm using that as an example to kind of give you a framework for how we who get involved in fighting light pollution and need to frame the problem. Any light that's emitted above horizontal is called uplight. The light that goes down onto where you're trying to get it, the task area, is useful. And then there's this slice just below horizontal, which creates a lot of glare and a lot of problems for people. So those are the three. And, you know, we've all seen, and I will show you a little bit later, images of the Earth taken from space at night. And you see this, you know, this blanket of lights from cities around the globe. And that is light that is headed straight up toward the zenith in the night sky. And you might think that that is the worst possible kind of light pollution, but actually it's not. This is a computer simulation that shows how much sky glow is created, how much scatter is created in the atmosphere by beams of light emitted at different angles. So the top panel there is a narrow cone of light that's heading basically straight up. And you can see that the amount of scatter is relatively limited. And if you think about it, that makes sense because our atmosphere is very thin. And once those photons exit the atmosphere, they can't create any more scatter. The lower two panels show what happens when that beam gets closer and closer to horizontal. And the one at the bottom is just above horizontal, within 10 degrees above horizontal. And this creates scatter for tens of miles, tens of kilometers in the sky, far away from the pattern. I live probably around 40 kilometers from downtown Boston. And when I look straight up in my sky, which is pretty dark as suburbs go, but when I look straight up, part of the light pollution, part of the sky glow that I have to deal with is created by lights 40 kilometers away in Boston that are sent almost above, just above horizontal, like that bottom panel shows. So here are some of the most wanted lists in this war against light pollution. We don't have as many of these now as we used to, but and maybe I have no idea what the lighting situation is in Philippines, but for many, many years, street lights were used this kind of shape. It's kind of like a glass salad bowl underneath a metal housing. The glass was actually a lens that refracted the light, and the light bulb itself was below horizontal, so that a lot of the light went down, but some of it still went up to the side. Later design created a flat bottom, and the light was actually tucked up inside here. And that was better because it at least forced all of the light to come out and below horizontal. By the way, again, I'm not sure what your situation is in the Philippines, but here in the US, all of these, all streetlights have a little sensor, shaped like a small cylinder on top, which senses twilight in the evening and dawn approaching in the morning, and causes the light to turn on and off automatically. This is one of the worst kinds of fixtures from the standpoint of light pollution. It's what we call a wall pack. It would be the kind of fixture that a business would slap above a doorway, both to illuminate the doorway and maybe to illuminate the parking lot beyond. It's a horrible kind of fixture. And this is the kind of, as seen from the side, this is the kind of beam spread that you get up and out and down, but a lot of it goes into the sky. And I call your attention to this particular fixture because the business that has this should know better. It's the Regional Research Office for the U.S. Environmental Protection Agency here in Chelmsford. It's just not a good example to be set. This is another really bad kind of lighting here in the Northeast U.S. If you're a business and you don't want to expend the money to create your own parking lot lighting, you can ask the utility to put lights on the poles that run along the street. And that's very economical from the business point of view because you don't actually have to pay for these things. The utility puts them up and then turns them on, and they are just awful with a capital A when it in terms of light spread. And for those of you who might be interested in trying to take some pictures of really bad light fixtures at night, I suggest that you wait until it's a foggy night like this was, because then you get to see all those, the beam spread really, really easily. Now, one of the growing areas of concern, at least here in the US, is sports lighting. And it's an interesting example here. This is the United States Tennis Association national facility outside of New York City. And on the right here, you see some older style lights, and you can see the horrible glare, and you can imagine how bad these are for the nighttime sky. On the left are modern, very well shielded fixtures created by a company called Musco, which is leading the industry in terms of creating dark sky friendly lighting. All of those light fixtures are on. You almost can't tell that they're on because the shielding is so good. So let's tick through the 5 things that light pollution does to really create problems all around our world. The first, and the one you're probably most familiar with, is the loss of the starry sky. Now, here in the US, about 20 years ago, we had a really widespread blackout in the Northeast, and whole chunks of southern Canada and the Northeast went black. You can see here what would be Detroit and Cleveland, Columbus, those are all dark. Toronto's dark, Ottawa's dark. Here in Boston, it's unchanged. So an amateur astronomer living in Toronto took advantage of this blackout. This took place in August, so the Milky Way was high in the sky, to take a photo of the beautiful Milky Way as seen over downtown Toronto during the blackout. These lights down here in the bottom are candle lights in his house. The next night, the lights came back on. He retook the photo, and this is what he got. And this is, I'm sure, a familiar scene for all of you, but it demonstrates pretty graphically what we have lost to sky glow in our modern society, how many of the stars we just can't see. Now, here in the US, the National Park Service has undertaken a multi-decade process to try to characterize the quality of the night sky over its parks, with the understanding and the realization that the nighttime environment is important too. So they had a team of amateur astronomers go around the country. This was in one of our darkest national parks in Utah. You can see the map here where it is. Yeah, this is a light pollution map down here in the lower corner, left corner, and you can see that's just black where this is. And in fact, this is a pretty dark sky. So the circle is a fisheye photo, an all sky photo. And then this is a panorama at the top going all the way around the horizon. There are a couple of small light domes from towns in the distance, but most of the light you see here is from the Milky Way. And so that's great. That's what you want. You want your prominent light sources to be the stars themselves. Now compare that with this same technique, color coded for intensity, taken from the Mojave Desert in Southern California. And toward the east, toward the northeast, is this huge light dome on the horizon from Las Vegas. Now, these color-coded maps were actually derived from actual photos. Here's one of those photos taken by the team. And you see this sort of artifact in the sky, this streak. That is not an artifact, that is real. That is a searchlight pointing up into the sky from the top of one of the casinos in downtown Las Vegas. And here we are about 50 kilometers away, and it's still very obvious in the sky to the camera. A little bit closer to where I am, and this is a kind of a battle zone, if you will, is a park called Acadia National Park. It's actually an island as part of Maine. And the sky is pretty dark generally. It's the same scheme. Here on the horizon is a little blip from a town called Bar Harbor, which is the largest town. This area is trying to get certification as a dark sky place, a dark sky park. And so Bar Harbor and the other towns have gotten together, and they're trying to improve their lighting, enact ordinances and regulations that will beat down the light pollution, because this is an area that a lot of astronomers go to. A little bit closer to the West Coast, some of the parks have already undergone major overhauls of their lighting in an attempt to make their nocturnal environment as good as it possibly can be. In Yosemite National Park, they brought in lighting designers, so you'll see a lot of very low-level amber lighting that is not disruptive to the nighttime environment, but still allows people to see and move about. It's also happening has happened in the Grand Canyon National Park, for example. So I'll say this a few times, the International Dark Sky Association, which is sort of the champion in the fight against light pollution, has created this certification program for places that have done the right thing. They're either naturally dark or they are trying to get dark. And you can see there are different categories here. And some of them are in the Rocky Mountains of the US, which is pretty dark generally. But some of them, you see a few here, there are places like in suburban Chicago here and in southern Florida. So this is a growing program. It's a quite rigorous process to get certified by the IDA, and that's a program that's ongoing. So number two is what we lose visually when we encounter light pollution at night. There's go through a little physiology here. Our eyes see using two different systems of sensors in our retina. During the day, we use what are called cones. That's what gives us our color vision. Cones respond to a lot of light and show us what color is. And I want you to notice that the peak of their sensitivity is sort of in the green-yellow part of the spectrum. Then when it gets dark at night, the cones stop functioning. There's not enough light to trigger a color response. And our rods take over, what we think of as our night vision. When we get dark adapted at night, it's the rods that are doing that work for us. And they are much more sensitive to light. This is a log scale here on the y-axis. And so rods are 1,000 times more sensitive than the cones are. But two things about that. First of all, their peak sensitivity is in the blue-green part of the spectrum. And the second thing is that rods are not a color system. So we can see well at night, but we only see shades of gray. Now, where that becomes important is when we try to get dark adapted, our eyes work pretty well at night. We can see in pretty dim light. We all have experienced walking around at night with just by the light of a full moon. It's easy to do. When we get a strong source of glare like this security light in our field of view at night, the rods and our eyes react badly to that. Our pupils contract and let less light in, so we can't see in the dark corners as much, and whatever dark adaptation we've accumulated gets wiped out. And so when you have a source of glare like this, you miss some obvious things. Like in this case, you miss the guy standing in the open doorway. So, one of the things that we in the IDA are trying to do is to get rid of glare. Yes, we're trying to get rid of light pollution, but glare is one of those symptoms that is very obvious to everyone. It becomes especially a problem for older citizens because our eyes, start to fail us. They get cloudy, we get cataracts. And the same blue light that creates blue sky during the day creates all the scatter, most of the sky glow at night. It's a process called Rayleigh scattering, and I won't get into it too much, but suffice it to say that blue light creates more scatter, creates more harsh conditions for our eyes, is more disruptive to the nighttime environment. And as you'll see, it is sort of the bad guy, if you will, in this light pollution game. Let's talk about those environmental consequences. Do you realize that 70% of all creatures, lizards, amphibians, higher order creatures, insects, are nocturnal at some level? They do something at night. A lot of species only do stuff at night. They migrate, they mate, they eat. And so light pollution is very disruptive. Here in New England, nothing is more symptomatic of that problem than the problem we are having keeping our fireflies around. Fireflies, do you have fireflies in the Philippines? Yes? Okay, well, here fireflies come out, they come out right at dusk, and the males are showing off, as happens with many species, trying to attract the females. And the problem is that if there's a lot of light pollution around, they are not as obvious. And in fact, studies have shown that with a lot of ambient light pollution, the females don't even show up. The males can be out there flashing their little tails off, and the females are just not around. So that's not very good for the future of fireflies. The other thing that you might not realize is that there are a whole class of insects that are nocturnal pollinators. They are the ones going from flower to flower, but at night. Moths especially are nocturnal pollinators. And the presence of outdoor lighting causes them to just not be as active. Less pollination takes place. So pollination is really bad in the presence of light pollution. And more broadly, you might have heard of this term insect apocalypse. If you haven't, go look it up. It's a real thing. The worldwide population of insects has declined by 75% in the last 50 years. That's a staggering number. Now, there are a lot of reasons for that, but a major reason is light pollution. And in particular, I'm sure you've all noticed that insects at night are attracted to bright lights. When that happens, up to a third of them are dead before morning from just through having been attracted to that light at night. I could go on. Birds, the migration of birds is affected by light pollution because they use stars in their navigation when they're migrating. This is a map of the United States and the major migration routes that birds take. And little known fact, songbirds in particular migrate at an altitude of 100 meters or less. And so they are very susceptible to the presence of lit buildings, skyscrapers in their path. And when that happens, rather than traveling in a straight line like on the left, following just, for example, moonlight as a guide, when they see a bright building, they like, if they want to keep it off their left wing, for example, they'll move in a circle around it, and eventually they are just exhausted and they drop from the sky either dead or exhausted. It makes them easy prey. And here in the United States alone, more than 600 bird deaths annually are attributed to collisions with buildings during migration season and at other times because those buildings are lit at night. It's a staggering toll that is taken on our birds. One last example I'm going to give you is sea turtle hatchlings, most prominent in tropical climates. The sea turtles climb out, they plant their eggs, bury their eggs in the sand on the beach. The hatchlings, once they come out of their shells, are trying desperately to get to the water as quickly as they can, which is easy to do if there's no lights around because they see glints off the waves, and so they know to go there. But if there's development or buildings in the way, they go in the wrong direction, sometimes crossing road, and they become easy roadkill. Sorry for the gross photo, but that's just what happens, especially here down in Florida. Number 4 is human consequences, which is an emerging area of research. When you are awake during the daytime, the amount of a compound called melatonin in your bloodstream is very low. Melatonin is an amazing compound. It has all sorts of beneficial effects for our bodies. One of them seems to be that it fights cancer. And so during the daytime, we don't have very much melatonin in our bloodstream. But at night, when it gets dark, there's a sensor in your eye that connects to the pineal gland in the brain, which manufactures melatonin. And when it gets dark, you don't even have to be asleep. Your brain produces lots of melatonin and injects it into the bloodstream. And that's where our melatonin is replenished at night. Now, if you happen to get up in the middle of the night and go to the bathroom or make a raid on the refrigerator for a late night snack, and you turn on the light, your melatonin crashes, the production crashes, and the body has to start all over again. So it became apparent more than 30 years ago that people who have jobs that keep them up at night and exposed to light, think taxi drivers, emergency room nurses, graveyard workers working in a factory overnight, have their circadian rhythm, their day-night rhythm completely messed up by this constant exposure to light. And it turns out that those people have a higher risk, breast cancer in women, prostate cancer in men, just by the disruption of their circadian system. This is a little graph that shows a lab experiment where laboratory mice were implanted with human breast cancer tumors. And then the researchers watched what happens. Some of those mice were exposed to constant light, and that's the curve here on the left, and the tumor growth was extremely rapid. And yet the mice that were kept in complete darkness, the open circles, their tumor growth was much slower because the amount of melatonin in their bloodstream was maintained. And so it's been determined and announced that shift work that involves this kind of circadian disruption is probably carcinogenic to humans. I would not want to be one of the people living in this apartment complex with all those lights shining into the windows at night. And here in the US, the American Medical Association has gotten into this and declaring that nighttime lighting disrupts all kinds of biological process and is potentially harmful to human health. So we know what the enemy is, and it's this light at night. And again, especially blue rich light. And finally, energy waste. Again, you've all seen these pictures of the Earth from it's taken by satellites, how the lights of cities delineate all of the major places. This is the United States, and clearly you can make out all the major cities. Here's Florida down here, Los Angeles over on the lower left, Chicago and New York and New England up here where I live. If you look closely at this, there are some places here in North Dakota and in West Texas where there are no cities. There shouldn't be any light there. And these are places that have extensive oil production, fracking, where it goes on 24/7. And so all of those oil fields are lit up strongly with light, and enough so to be seen easily from space. It's a pretty sad situation. Okay, so let's talk about light pollution near the Philippines, shall we? Here's a map, a color-coded map showing light pollution in southern and Southeast Asia. Here's India over here on the left. Here's Vietnam, Hainan Island, the coast of China, Malaysia, and then here on the far right, here's the Philippines. And let's zoom in a little bit on that. Here are your islands, and obviously Luzon is the one that has the highest population and therefore the most light pollution. We were talking before we got started about how some of the outer provinces and even northern Luzon itself doesn't have much light pollution. Again, these are color-coded maps. So the reds are the most light pollution, yellows, greens, blues are pretty dark. So it turns out I can quantify this a little bit. I've zoomed in on Manila and its surroundings. I've drawn a box around it, and I've analyzed how much light pollution you have had over the last decade. And by the way, this is down here on the graph, this is the website that you want to go to, lighttrends.lightpollutionmap.info. And you can play this same game that I have anywhere that you want in the world, but especially there in the Philippines. And so this shows the growth in light pollution over the last decade or so, since 2013, as measured by satellites. And that dashed red line shows the increase, which turns out to be about 4% per year. Now, that's bad that it's that much, but it's only a lower limit. These modern satellites that take these photos looking down at the Earth are blind to blue light. So they see the red light, they see the green light, but they don't see the blue light. And I'm sure you're all aware that there's been a growth of LED light fixtures in the nighttime environment. Those are very strong in blue light often. And this is a problem worldwide. It's not just in the Philippines. I get increases like this all the time. So just 3 weeks ago, in the journal Science, a team of light researchers, light pollution researchers, announced a result of an analysis of measurements taken around the world over the last 11 years. Oops, I'm sorry, I didn't mean to do that. And what they found is that worldwide, there's been an increase in the sky brightness, in the sky glow, of from 7 to 10% per year. Now, from the standpoint of us trying to observe the stars, that is just not sustainable. That is a scary and sobering number. And it sort of goes back to the fact that these plots, when you make them, they're not showing you the full picture. And what they were able to do here, I'll get back to this, is that they're using observations made by citizens on the ground, actually measuring the brightness of the night sky. I'll get back to that in a second. So these LEDs, these light emitting diodes, have come on the scene. There's no way to understate how dramatically LEDs have affected our nighttime environment. It is a change in the way we light the night that happens once in multiple generations. The last time we've had a technology that has been so dramatically impactful was back in the 1950s and 60s. And so I have to say, LEDs are a phenomenal technology in terms of their energy efficiency, as shown by this plot here. We think we can get, 250 lumens, which is a measure of light, quantification of light per watt of electricity, whereas an incandescent bulb that everyone was using like 30 years ago is only about 10 lumens per watt. So they're dramatically efficient, and they can do all kinds of things extremely well. They can be dimmed. They can be made any color that you want. They can turn on and off, with no time delay at all, seconds, thousands of times a night if you want them to. But there's a dark side, if you will, an ugly side to these LEDs. So I'm going to introduce you to something called color temperature. For those of you who have studied astronomy and know about blackbody radiation, you know that the hottest stars are the bluest stars. They emit the greater their light peaks at the blue end of the spectrum, and the cooler the star, the redder its appearance, the redder its spectrum. And so lighting people have taken this notion of this sort of color temperature equivalent for color and used it to describe the apparent color of lights. And so now when you get when you buy a light bulb, you're going to see a number on it, which is its color temperature in kelvins. That ranges anywhere from, well, typically you're going to see them around, where you might buy them in a store, 3,000, 4,000, maybe 5,000. But you see here graphically the range of color temperatures. And in fact, here in the US, when you go to a store to buy a light, it tells you on the packaging what the color temperature is. That's a fairly new development on the labels of all the lighting that is purchased by the consumer, and for commerce too as well. So I want to get back to this notion of rods and cones. Remember, our eyes at night are more sensitive to blue light. In fact, they are most sensitive to blue light. Before LEDs, a lot of our lighting was using what's called high pressure sodium, or HPS lighting. It's got that kind of peachy color. You'll know it when you see it. It's not really white. It's kind of a warm glow. And that's because it really does not emit any blue light at all. All of its emissions are in the yellow and orange part of the spectrum. But compare that with what an LED does. These are two LEDs side by side, and just sort of intrinsically, an LED, a naked LED, if you will, creates a huge blue spike of emission. And you can, just like with a fluorescent bulb, you can change the color of an LED by taking that emission, coating the inside of the LED with a phosphor that absorbs the light and then re-radiates it at some other spectrum. And so this 3000K here, you see that the blue spike has been greatly diminished, and this will be a light that has a lot warmer color to it. The reason this is all important is the dashed line that you see in this plot. That dashed line is our sensitivity, our circadian sensitivity. That little sensor in your eye is most sensitive to blue light. And in particular, it is most sensitive exactly where LEDs put out the most light. And so this is why at night, if you're exposing your eyes to blue light from an LED, or your device, your phone, your TV screen at night, which has a lot of blue light in it, you're suppressing your melatonin production, and you're not doing yourself any favors. So the three curves here are the dashed line is circadian sensitivity. The solid line is our photopic sensitivity during daylight. This is what our cones are sensitive to. And then this heavy black line is the output from a 5000K LED. Very bad news at all. I'm going to kind of skip through this. A lot of people will claim that 4000 LEDs, 4000K LEDs are acceptable because they're just like moonlight. That's really not the case. The moonlight is actually a lot more similar to a very warm light than to a bluer LED. So I'm going to skip this. So the American Medical Association again weighed in on this just about 2016 and encouraged the use of 3000 Kelvin or lower in lighting for all outdoor installations. And I have to say, the person who was most responsible for this AMA policy is a cardiologist in the Boston area named Mario Matta. You perhaps have heard his name. He is an outstanding amateur astronomer. Edwin, Imelda, and I have all known him for a very long time. He's got a 32-inch, that is not quite 1 meter, telescope in his house, mounted on his house that he observes with. He's quite the guy, but he has led the fight on this AMA policies. So what can we start? I'm going to sort of segue here into what we can start to do. Maybe there are places in the Philippines that have not yet converted their street lights to LEDs. If so, you have a responsibility to your fellow stargazers and to yourselves to get involved in that selection process, because often LEDs are chosen by people who don't know anything about lighting. They pick a fixture that looks really nice during the daytime, and at night it can be horrible. Horrible not only from the standpoint of the color temperature, it's too hot, it's too strong, it's not shielded well, it creates a lot of glare. And so if you, throughout the Philippines, were to educate yourselves a little bit, just a little bit about the good, bad, and ugly of outdoor lighting, you can make a difference if you can if you can insert yourself in those discussions. I want to show you the leading edge of LED technology here. This is a little town nearby where I live that decided to change its street lights to LEDs. And it turns out that there's a very active astronomer, amateur and professional astronomer, who lives in this town, and he convinced the town to install a bunch of test fixtures before they made the complete conversion, and to let the people in the town vote on which ones they liked best. And what they liked best was something that was a real warm color. So These are two side-by-side pictures that I took. One of these is the high pressure sodium fixture that was replaced, and the other is an LED that has been installed. You can't really tell them apart. They have the same warm glow. Look at the street. It's got this warm glow on it. I haven't doctored these images at all. It's exactly as they were taken by the camera. Well, the one on the left is the LED. It creates less glare. You can see it's not as bright as the other one is. It's obviously lower cost. It's the one the citizens favored, and you can see that that it actually covers the street more uniformly. So when I got involved with this game about 30 years ago, those of us who were fighting light pollution were seen as a little bit on the fringe, if you will. We were, we were astronomers trying to preserve the darkness of our mountaintops, and we really had no grounding in the reality of everyday life. But now, all these years later, light pollution has become a kind of everyday topic when it comes to, preserving insects and pollinators and bird migrations, and for all this energy savings, all those reasons. And this is just an example of some of the stories that have run here in the US having to do with light pollution. This National Geographic, by the way, this is downtown Chicago, sort of the poster child for bad lighting. So what I encourage you to do is, if you want a short version of what you're hearing this evening, is go to the IDA's website, darksky.org. That's your one-stop location for all things having to do with light pollution. And in particular, look for a short public affairs film called Losing the Dark. You can also find it on YouTube. And it's been translated into a whole bunch of different languages. It's about 10 minutes long, and it gives you a sort of snapshot, something that you could easily show to local officials, for example, about lighting. Now, an important development happened just within the last couple of years, where the IDA has partnered with a group called the IES, the Illuminating Engineering Society. This is an important group. They set all the standards for lighting here in North America. And so the two of them got together and have put forward these 5 principles for responsible outdoor lighting. And you can see them there. Light should be directed only where you need it, no brighter than necessary, only on when it needs to be, and the warmest color temperature possible. This is a sort of graphic that shows what we mean by those things a little bit. And this has really caught on. So this is the guiding principles for controlling light pollution. Now, there is something you can do, and I want to get back to this result from Science Magazine from a couple weeks ago. You see here where it says, using 51,351 citizen scientist observations of naked eye stellar visibility. This was not satellite data. These were estimates of the naked eye limiting magnitude that people like you and I around the world took year after year after year. And the program that does that is called Globe at Night, globeatnight.org. I want you to all, when you're done here, whenever you hear this talk or see this talk, if you're watching it on Facebook or if you see it later, when you're done watching, I want you to go to globeatnight.org and make a difference in fighting light pollution. And it's really simple. You don't need any experience. You don't need any equipment. All you have to do is be willing to go out under a clear, dark, moonless sky and to estimate how many stars you can see. And so you go to this website and it provides little maps like this that show you how many stars will be in the sky for various degrees of darkness. Magnitude is a number that astronomers use to describe how faint the stars can be seen. The higher the number, the fainter the stars, as these maps kind of indicate. So you go to the website, and you can do this on your app, which has the advantage of already geolocating where you are. And you enter just a few pieces of information, the time and date, where you are, what the sky conditions are, or is there anything unusual? And then which of these little maps is closest to what you see in the sky. Make sure you give yourself a little time to dark adapt. at least 10 or 15 minutes before you make this observation. And then you hit send, and it becomes part of that global database that those scientists tapped into in order to make their results known. Now, there's a shortcut called a sky quality meter, or SQM. And as members of astronomy clubs, I encourage you to get one. This is what it looks like. It's the size of like a package of cigarettes. It's very simple. It's got a little button battery inside, and you can use it to make a quantified measurement of how dark the sky is. And you can include that in your globe at night observation, and it makes it much more valuable because it takes the guesswork out of it. You know, we humans, as we get older, our pupils don't expand as much at night. We can't see as faint a star as we could when we were younger. And so the sky quality meter takes the guesswork out, but it doesn't matter. You don't need that meter. You can just do this on your own. Do it over and over again over the course of the year, over many years, and that will show you where things are going with respect to your night sky. So I called up the globe at night observations for in and around Manila for last year. And as near as I can tell, there were 4. You can see them here barely. There's 3 little yellow circles, which suggests that you have pretty crappy skies in downtown Manila, as I would expect, right? Then over here, not far away, there's somebody who says that you had a limiting magnitude of 7, which I absolutely do not believe absolutely at all. As I said, these are 2022 results. When you invite me back next year for next year's National Astronomy Week celebration, I want to be able to call up the 2023 map and have this whole area, the whole islands of the Philippines, peppered with globe at night measurements. I hope you will make that pact with me. That is your homework for the coming year, to get involved with this. At the end of the day, we can individually do something to fight light pollution, be it a globe at night measurement, or going to our local municipality and say, hey, tell me about the lights that you just installed, you know, or what did you ask of the developer that put in those awful lights, or maybe there's a development going in and you can control what lights get put in beforehand. The point is that we need to put in lights only when and where we need them, and in just the amount necessary, because everything else is waste. It's waste. So here are a few key links for you. Here's my information, and there is my US phone number. Please call me if you have a question or write me an email. I am very good about responding to people. This is what I do in retirement. I am very passionate about fighting light pollution. I want to make all of you passionate about fighting light pollution as well. And Jet, I'll turn the floor back to you. Thank you very, very much. Maybe we can take some questions.
Thank you so much, Kelly, for that very, very informative talk. As I mentioned, we live, unfortunately, our group, most of us are here in the cities, and that really affects us. And we will take your challenge to start doing dark sky measurements of light pollution, and try to come up with data for you next year, hopefully. So I would just like to read some of the questions here in the chat box. One of the questions here is, does man-made lights affect nighttime lights from the sky? But does man-made lights affect nighttime lights from the sky?
And Tristan, yeah. I'm going to, by lights of the sky, stars, for example, okay? Yes, absolutely. I'll give you a real good example that's happening right now. You may have heard about this comet ZTF that has been cruising across the sky, and it is visible, but it is a soft object. You know, it's not a point. It's actually a fuzzy ball in the sky. The more light pollution you have, the less your chance of being able to find that, because it's an object like that really just kind of gets blended into the background of the light pollution. So absolutely, not just objects like that, but the stars themselves are the faint ones are just obliterated from being able to be visible. that measurement of I was showing of magnitude, if you were in a, let me try to make it in simpler terms. If you were in a super dark location, there was no moon in the sky, no lights of any kind anywhere around, you might be able to see a couple of thousand stars, 2,000 stars, 3,000 maybe, with your eye in the nighttime sky. If you live in the middle of the city with a lot of sky glow making the sky bright, you guys who live in and near Manila can tell me better. If you see 30 stars, you maybe are seeing a lot, right? So that's how many stars you lose to light pollution. And so the less light pollution you have, the more stars you're going to be able to see. And, you know, if one thing I want to mention, we humans, long ago, there wasn't electricity and there were no street lights at night. And we evolved as humans, you know, 1 million years ago, being exposed to really bright daylight during the day. We spent a lot of time outside hunting and gathering and stuff like that. We were exposed to full spectrum sunlight during the day. And then at night, it was black. It was dark. We lived in a cave maybe. And so this range between really bright days and really dark nights set our circadian rhythm very strongly. And we had very strong circadian rhythms. Now think about your everyday life. You spend your day maybe in an office or a school or, you know, some kind of building, and you never really get exposed to much direct sunlight. It's kind of a gray all the time. And then at night, we've kind of extended day into night. We're up until really late at night, or we watch TV or play with our devices. We go to the malls and the all night fast food places. And so we've really messed up our circadian rhythm in ways that we don't fully understand yet, but it can't be good.
Thank you, Kelly. I also like your discussion about the medical aspects of light pollution, and I look into it as well because I'm a medical doctor. Thank you about that. There's a question here from Mr. Tomas Encarnacion. How do observatories deal with light pollution, especially those located near urban areas? Do they have a way of dealing with light pollution, the observatories?
Well, I hope Deborah will weigh in on this, but let me tell you what I think I know. And that is that observatories, there was a time when observatories were on the outskirts of what was then the city. At Harvard, there is an observatory in Cambridge, which was at one point a very, very dark location. In Sydney, there is an observatory on a hill in the middle of downtown Sydney. I'm sure that the observatory that was established there in Manila, I was trying to remember the slides, like maybe in the 1930s, if I remember right. At that time, it was probably a pretty dark location. Now those areas are completely swamped. Those telescopes, as beautiful as they were, and a lot of them are beautiful old refractors, are just used for outreach. They'll show you the moon and planets, and that's about it, because that's about all they can see any longer. And professional observatories are being affected as well. I'll just use the example of Tucson, Arizona, which is home to Kitt Peak National Observatory, the largest collection of professional telescopes in the United States. And it was during the 1980s that a couple of the astronomers there, Dr. David Crawford, noticed that the growth of neighboring Tucson was starting to affect the night sky from the top of Kitt Peak. And that's how the International Dark Sky Association got formed. It was initially, you know, the scope was worldwide, but the focus initially was trying to get Tucson to diminish its lights. And they were very largely successful. Tucson is still, for the size of a city that big, it's still a pretty dark place. Deborah, you want to talk about other locations?
Yeah, thanks, Kelly. What you said is exactly right, and this is affecting observatories everywhere. In some places more than others. Chile has done a good job of trying to control light pollution around the observatories there, although, again, lights are starting to affect even what were once very dark sites. South Africa is still doing a very good job because they have some very dark areas where their observatories are located. But it's a growing problem. At my campus, we have a 32-inch telescope in the middle of Poughkeepsie, New York, and the skies are not great there anyway, but at least we've been able to convince our administrators that we need downward pointing lights, and we also need to have control over these lights. We need safety, but we also need, if we have a deep exposure, the ability to turn off the lights. So very locally, you can have some influence over your observatories if you talk to the administration and convince them that if you're going to do some research or public outreach, that you need to be able to have regions where you really can control what the lighting is. But it's a problem everywhere.
Thank you. Thank you, Deborah. Another question for Kelly from Mr. Raymond Ang, and this is some practical aspects. The question is, for colleges and universities in light-polluted metropolitan areas like in the Philippines, would you recommend investing in research projects using small to mid-sized telescopes rather than invest in large aperture telescopes that may be affected with light pollution?
Right. So let's think about the kinds of objects that you can see through light pollution, which is still stars. And one of the most productive ways that even the telescopes in even light polluted areas can be useful in research, in like actual contributions to science, is photometry of stars. That is measuring the brightness of stars or double stars, variable stars, all of that. And more recently, to measure the transits of exoplanets across the disks of distant stars. That is something that can be done from a light polluted area. And so in that particular case, as it has always been the case, the larger your aperture, the fainter the star you can see. So if you were to undertake a project involving any kind of stellar work, spectroscopy or photometry or astrometry, any of that involving stars, then that's where I think you will have the most success in a light polluted environment. If you're looking for trying to map the H2 regions and the galactic arms of a spiral galaxy or Andromeda galaxy or whatever, not so much, because you can't see the faint stuff, but you can certainly see the stars. And so there's a whole range of opportunities, not only for small apertures, but for large apertures as well.
Thank you, Kelly. And this is another good question regarding addressing the problem of light pollution from Mr. Christian Dimacali. Hi, thanks for the great talk. I am an IDA advocate and always share about light pollution and dark skies to the general public, but I'm having a hard time reaching out to politicians or other officials. Do you have any tips for me to reach out to these people in power?
Yes, I do, Christian. Let me give you 2 bits of advice. Then, first of all, thank you for being an IDA advocate. IDA advocates are individuals like Christian. They're not engaged in a club, although I am certain that the National Astronomical League of the Philippines will very quickly have a light pollution committee on it, right? Right?
Yes,
Yes, okay, good. So as an individual, if you have an existing problem, let's say there's a mall or something, then what I would do is I would talk to the officials or talk to the mall owners. Let's say, look, you're not going to change your lights, but maybe you can shield them. Or maybe they're LEDs, in which case almost every LED has the ability to be dimmed. There could be just a switch inside the housing. And maybe the light is brighter than it needs to be. Or maybe that LED can be, a timer can be attached to turn it off when there's nobody at the mall. You know, you think of a big mall, they have huge parking lots that are completely empty at night. Sure, you want to protect the building, but you don't need to protect all that asphalt. So maybe you can convince them to just turn off the lights at night. That's for existing facilities. This applies to municipal facilities as well. In terms of the really easy victories are for the things that have not yet been built. And so, Christian, what I would encourage you to do locally or even nationally is find out what the, I don't know how utilities work in the Philippines, but if there is a national utility that provides all of the power, what is that utility's plan for converting street lights to LEDs, just nationwide in the Philippines? If you can find the right person, you can affect something simple like the color temperature of those lights. Maybe they're planning to put in 4,000, you can convince them to do 3,000. Or maybe they were, here's something that nobody really understands unless you point it out to them. A given light has a lumen output. And so if you replace an existing, that orange high pressure sodium light with a blue rich LED, and they have the same number of lumens, the LED will look much brighter because of the blue light. One of the demonstrations that I use is I go to the hardware store and I buy 2 small LED bulbs that are exactly the same output, but one is 2,700 Kelvin, which is typical in a hardware store. It's got a nice warm light. And the other is, say, 4,000. It's a bluer light. They have the same lumen output. And I turn them on at the same time. And the blue one looks a lot brighter because of our eye sensitivity to blue light. And it gives a very good demonstration that you don't need as many lumens with an LED as you used to. These are the kinds of things that the IDA advocacy program, and Christian, again, I'm glad that you're an IDA advocate. I hope you've tuned into some of the tutorials that we've had. You can be taught these basics about lighting by the IDA. We have a whole series of tutorials that can bring you along step by step and make you much more conversant and much more expert at the, what goes into lighting, good lighting and bad lighting.
Thank you, Kelly. And we will make sure that the Astronomical League of the Philippines, and we will also join our other astronomical groups to also be IDA advocates as well. Thank you so much. And those are very practical tips, how to address those questions with our administrators and politicians. I think I read the last question. This is a technical question, Kelly. How does light pollution or smog make light pollution worse? How does pollution or smog make light pollution worse? How many orders of magnitude? How about the humidity? Given the tropics have hot and humid air, then air pollution added to light pollution. And a follow-up, are specific colors or wavelengths of light more impacted by smog or water vapor in the air? Which ones are more scattered by the smog or water vapor?
Very good. Very good. Those are great questions. So yes, we have this too in the United States. During our summers, the air is often very hazy. There's a lot of aerosol content in the atmosphere. And so just air molecules themselves, no haze, no smog, just the molecules themselves will scatter light. That's why the sky is blue. It's a process called Rayleigh scattering. And it turns out that photons of light are scattered according to the inverse fourth power of their wavelength. What that means in practical terms is that blue light is scattered something like 16 times more readily than red light is. And so at night, every blue photon that goes out from an outdoor light at night is going to create a whole lot more scatter than a red or leave an amber or warmly colored light would be. That's why the name of the game, the success will come with trying to reduce as much of the blue light as we can. When you get aerosols in the atmosphere, those are actual particulate bits of particles, be they, smog particles or air particles, water vapor, just fog and that sort of thing, then those are large enough to scatter all wavelengths of light, not just the blue ones. And so the scattering becomes much, much worse. You'll all know that the sky seems to glow a lot more when there's haze and cloud around than when it's a clear, transparent night. And that's how it gets affected by the wavelength of light. There was an interesting study in Los Angeles undertaken by atmospheric scientists here in the United States. It turns out that light pollution makes smog worse. Light pollution from a city makes smog worse over Los Angeles, and it's too complicated to try to get into now. But there was a feedback mechanism that LA has a pretty bad problem with smog, and it's made worse by the fact that there are all these lights shining into the sky at night.
Wow. Thank you, Kelly. There's another question here in the Q&A from Mr. Jason Kalau. Hi, thank you for the good discussion. I am involved in a research for light pollution here in the Philippines. One of the obvious contributors of ALAN is the digital billboard. I think these are the LED digital billboards, which we see a lot in our streets. No? In your country, is there a standard size, luminosity, and kind of graphics that should be considered in the said billboards?
Yeah, that's a great question, Jason. Not a lot of cities have lighting regulations for billboards. But I'm sure in the Philippines, if you have a problem, we have a problem here. It's a growing problem. A lot more communities are paying attention to these digital billboards and creating regulations for them. There is no standard nationwide. It's on a city by city basis. Typically what happens is that you want the light intensity at night to be far lower than it is during the day because there's no daylight competition. And the metric that is used to determine the brightness of a billboard is something called a NIT, N-I-T. It's candela per meter squared. And so when you're trying to determine how bright you can allow a billboard to be, let's say you wanted to create a regulation, you would regulate the nits that billboard puts out per square, it's an amount of light per square area. And there are some towns that have regulations. If you want to look up, that would be a great question to bring up at an IDA advocates meeting. But as a shortcut, I know, for example, that the city of Pittsburgh, Pennsylvania in the United States, has a billboard limit of something like, I'm just guessing here, like 100 nits at nighttime, as in an attempt to try to control the brightness. And billboards are really bad because they're shining out horizontally, and because they're LEDs. There's a lot of light that goes up, a lot of light that goes down. There is some emerging technology that controls the emission angle of the light from a billboard, but it's not very widespread, unfortunately, not yet.
Thank you, Kelly. Thank you so much for patiently answering all our questions. In the interest of time, we have to proceed unless some of our panelists have a question or two. Well, if none, let me take this opportunity, Kelly, to give you our certificate of appreciation from the Astronomical League of the Philippines. This certificate is presented to J. Kelly Beatty for his invaluable insights, experiences, and expertise shared with the participants for his talk, The Fight Against Light Pollution, held as part of the ALP NAW 2023 opening program given this 19th of February 2023, signed by President James Kevin T. and Jose Francisco Aguilar, Vice President. Thank you so much, Kelly, and hope to see you again next year.